So when we're solving just general linear equations, we kind of have some steps that we follow no matter what the equation looks like. So the first thing we want to do is really step 1 and 2 are to simplify each side. If we see parentheses, we're going to distribute. And if we see any like terms on the left side or like terms on the right side, we're going to combine those. Once we've done that, once we've done step 1 and 2 and we've simplified both sides, we're going to have to move our variables to one side of the equation, our numbers to the other side, and then we solve like normal. So let's look at a couple examples of this. I'm going to draw a line down our equal sign just to keep our left and our right side straight here. Example 59, we can see some parentheses here, so that's a sign that we need to distribute. We're going to distribute the 4, multiply the 4 by both things inside of there. 4 times 2x is 8x. 4 times negative 6, negative 24, equals 16. Now you'll notice there are no like terms to combine. We cannot combine terms across our equal sign. That's why that line down the middle kind of helps us. And we also don't need to move our variables to one side because we already only have x's on the left side. So now we're just left with a normal two-step equation that we can solve. To get rid of that minus 24, we add 24. Remember, our ultimate goal is to isolate the variable. Those cancel. We bring down 8x equals 16 plus 24 is 40. Our goal is to get the x by itself. It's being multiplied by an 8, so we divide both sides by an 8. 40 divided by 8 gives us x equals 5. Okay, similarly on example 60, we do have some parentheses on that left side again. So we start off using distribution. 3 times 2x, 6x. 3 times negative 4, negative 12. Notice we do not distribute to that 9 because it's not inside parentheses. So we just bring that down. Equals 15. Okay, in this case, we do have some like terms on the left side. We have this negative 12 and this positive 9 we can combine. So before we do anything else, we're going to go ahead and combine those like terms. We bring down our 6x. Whoops. Bring down our 6x. Negative 12 plus 9 gives me negative 3 equals 15. Again, we just have variables on one side, only on the left side here, so we don't need to move our variables at all. We're just going to go ahead and solve this two-step equation. We can add 3 to both sides to eliminate that minus 3. Negative 3 plus 3 is 0. We end up with 6x equals 18. To get rid of that coefficient of 6, we divide both sides by 6. 6 divided by 6 is just 1, or 1x. So we get x equals 18 divided by 6, gives me 3. Okay, but let's look at a second type of equation here where we do see some variables on both sides. Look at example 61. If we draw a line down the middle, notice we've got x's on our left side and our right side. So we're going to have to add in that third step from above. We still talk through our first two steps. We see if we need to distribute. Well, we don't see parentheses, so we don't need to distribute. We see if we can combine any like terms, but remember we cannot combine across our equal sign. So there's no like terms on the left side, no like terms on the right side. So then our next step is just to decide where we want to move the variables. We want variables on one side, variables or numbers on the other side. It really, mathematically, it does not matter which side you move the x's to. In general, I like to keep the variables positive, so I'm going to move my 2x over here so that we keep it positive. We have a positive 2x on the right side, so if I want to move that from the right side to the left side, we do minus 2x. Let's see why that helps us. 2x minus 2x is 0. Now it's gone from the right side. And we only have a 10 on that right side. On the left side, 4x minus 2x is 2x. So we have 2x minus 6 equals 10. Again, now this looks like equations that we have solved before. We have two-step equations. We just solve like normal. We want to move our numbers to the right side, so we add 6. Negative 6 plus 6 is 0, and we end up with 2x equals 16. Just like always, to eliminate our coefficient, we divide by 2, and we end up with x equals 8. Okay, example 63 looks similar. We have negative 3x plus 9 equals 6x minus 27. We've got variables on the left, variables on the right. Just like the example before, there is no distribution to be done, and there are no like terms to combine. So now we've just got to move our variables to one side and solve. Again, mathematically, it does not matter where you move your letters to. If you always want to move them to the left, move them to the left. In this case, I notice that I have a negative 3x right here. So if I want to get rid of that, I can add 3x's. And then that's going to keep my variables positive. I'm not going to be working with a negative value of x's. So negative 3x plus 3x cancels, and I just have a 9 on the left side. 6x plus 3x is 9x. Bring down minus 27. Okay, don't let it throw you off that the x's are on the right side now. Our goal is still to isolate them. So I want to move the terms that do not have a variable to the other side. I'm going to add 27. And I end up with 36 equals 9x. Okay, we're still trying to isolate our x, so let's divide by 9. Divide by 9. And I get 4 equals x. Once our variable is isolated, that's our solution. Okay, let's do a couple more examples here where we have multiple steps going on. We're going to have to distribute, combine like terms, maybe move some variables, and then solve from there. Example 64 has a little bit of everything. Notice we do have parentheses. So we start out with distribution. We get 2x minus 10, bring down your plus 3x, equals x. And I'm going to write that as 1x just so we don't forget that it has an understood coefficient of 1. Plus 18. Okay, before we start moving anything, let's look at our left side. We do have some like terms we can combine. We have a positive 2x and a positive 3x. If we combine those, we get 5x. I'm going to bring down that minus 10 equals 1x plus 18. Okay, from here you have a choice. We have variables on both sides, so we got to decide where we want to move them. I'm going to move them to the left side. So to get rid of that 1x, I'm going to subtract 1x. 1x minus 1x is 0. It cancels. And I'm left with 4x minus 10 equals 18. We continue solving from here. Plus 10 plus 10. 4x equals 28. Divide by 4. Divide by 4. X equals 7. All right, and then one more here. Notice we've got 2 sets of parentheses on the left side. Our steps do not change. Just as we're simplifying that left side, we're going to have to distribute twice. First, we're going to distribute our 3. 3 times 4x is 12x. 3 times negative 5 minus 15. Now we distributed negative 4. Don't lose that negative with that number. We get minus 8x minus 4 equals 5. Okay, we do have some like terms we can combine over here. We've got a 12x minus 8x, and we've got a minus 15 minus 4. So we're going to put our variables with our variables, and we get 4x. We're going to put our numbers with our numbers. We get minus 19 equals 5. Okay, notice here we don't need to move our variables. They're already only on the left side, so we just continue solving from here. To isolate our 4x, we add 19. We get 4x equals 24. To solve for x, divide by 4. And we get x equals positive 6. Okay, so here we just kind of wrapped up. We wrote our 5-step process here that you can look through any linear equation that you're solving. But I want to look at a couple examples with you right here where we get some kind of funky solutions. We don't end up with something like x equals 2, x equals negative 7. So let's follow the steps we talked about, and let's go ahead and see what happens here. First step on example 67. We distribute to simplify each side. We get 6x minus 5 equals 6x minus 15. 3 times negative 5 is 15. Equals 6x minus 15. Okay, you might notice it already looks a little bit funny. You notice we have the same thing on our left side as we do on our right side. So if we decide we want to move the variables to one side, you'll notice it really doesn't matter which side we choose. because all of our variables are going to cancel. They're all going to eliminate. And I end up with negative 15 equals negative 15. Okay, notice we have no variables left to solve for, but we are left with a true statement. I'm going to write that here. This is a true statement. So if we have no variables remaining, but we have a true statement, negative 15 equals negative 15, that means our solution is all real numbers, or it can be shown by this symbol right here with that kind of funky looking R. What that means is no matter what variable what value we choose for our x, if we plug it in our equation, it's going to make it true. Okay, we have one more special case here. These last two examples are the special cases that you might see when solving. Our last example here, start the same way. We're going to distribute our left side. If we do that, I get 6x minus 10 minus 4x equals 2x plus 7. Combine our like terms, we get 2x minus 10 equals 2x plus 7. You can probably see what's going to happen here if we move our variables to the left side. All of my x's eliminate. They all cancel, and I'm left with negative 10 equals positive 7. Well, this obviously is not a true statement. This is a false statement. So if we have no variables left, but we're left with a false statement, that means that we have no solution. You can write the words no solution, or you can draw this symbol, which says no solution. So what this means is no matter what value we choose for our x, if we plug it in, it's never going to make it true. There is no value of x that makes this true.